In this animation, we explore how waves travel along a stretched spring. Although the spring itself stays in place, energy is transported as a moving disturbance. A long coil is stretched horizontally. This is our medium for our waves. One end of the spring is held under tension. The hand holding the end will be our input for creating wave disturbances. The hand begins moving back and forth along the length of the spring. Adjacent coils begin moving in response to changing tension. This motion creates regions where the coils compress and regions where they spread apart. These compressions and expansions propagate along the spring as traveling waves. Each individual coil moves back and forth horizontally about its equilibrium position, but does not move along the length of the spring. This type of motion is called a longitudinal wave, or a compression wave. In a longitudinal wave, the disturbance occurs along the same direction as the wave's velocity. The motion stops and the spring returns briefly to equilibrium. Now the hand moves up and down perpendicular to the length of the spring. This causes each individual coil to move up and down about its equilibrium position. The wave shape travels along the spring, moving away from the hand. The wave moves horizontally even though the coil motion is vertical. This type of motion is called a transverse wave. In a transverse wave, the disturbance is perpendicular to the wave's velocity. These examples show two different kinds of wave disturbances. A single longitudinal pulse moves through the spring, with the motion along the wave's direction of travel. A single transverse pulse follows, with motion perpendicular to the direction of travel. In general, waves carry energy through a medium without transporting the medium itself.